we have started a new chapter, that is chapter number 4, thermodynamics, in which we have seen what is syllabus of thermodynamics. So as we've seen, you most of the all familiar. Actually, it is not most, all of you familiar with that thermodynamics. Okay. So in thermodynamics, we have seen syllabus, then we have seen energy. So what do we have learned in previous lecture? That is in morning lecture. What is meant by energy?
Yes, sir.
No, I have asked, I'm asking question to you all. What is mean by energy?
Capacity of doing work.
Capacity to do work.
X.
It is the ability to do work, or it is the ability to do some changes. Okay. So most always it is not related to work. Energy transfer takes place in the form of heat also. At that time, it will changes in some locations or some in other parameters. Okay. So and we have seen we cannot develop energy, we cannot create energy or the extra energy, and all energy which is present in the universe is same, and also we cannot vanish it. Yes, but we have one option only, that we can change energy from one form to another form. But as we have seen, energy is the one thing, correct? Energy is only one thing, and it will appear in different phases, correct? So there are n number of phases. So some phases we know, that is we can see some forms, then we can feel some forms. For example, suppose water is heating. If this is the pot of water, and here this one is the water, and if we apply heat, transferring temperature, okay, and it will move, it will this temperature of that water increasing up to 60 degree. So at 60 degree, water will not boil. Am I right? Yeah. Yeah, it will not boil. When I close this, and if I ask you what is the temperature, so you don't have thermometer and all, so how will you check? How will you check? If you have two pots in which I put water which is having normal temperature, we can say 25 degrees Celsius, at normal degree Celsius, and this pot I will keep near to this, and which is having 60 degrees Celsius. So how you can understand difference in between them? Yes, simple things that we are checking regularly. In the morning, if you are taking bath with the hot water, so before taking bath, what do? You check. How you check? It is by only eyes.
Touch.
Yeah, with inserting hand inside the water. When you insert hand inside the water, you feel some hotness and the coldness. It means that this is the form of energy which we can feel, correct? We cannot see that, or we can see this. हे दोन जर ठेवलेले आहेत आणि याच्यामधलं मी म्हटलं की हे चेक करा, तर तुम्ही ओपन आपल्या डोळ्याने फक्त पाहून सांगू शकता का की हे बाबा गरम आहे आणि हे कोल्ड आहे, दोन्ही पण पाणी आहे, आपण सांगू शकतो का?
जर वाफा निघत असतील तर सांगू शकतोय.
नो नो, वाफा कधी निघतील?
ते बॉईल झाल्यावर
at 100 degrees Celsius. म्हणून मी तिथे टेम्परेचर लिहिलेलं आहे. So temperature is at 60 degrees Celsius. So there is no evaporation. So you cannot see some evaporations. Correct? So for that, to check hotness of that bodies, you have to insert your hand. correct? And if you want, and by inserting hand, you can tell only the water will be hot or cold. Okay. So
Yes, sir.
this is the form of energy that we can feel, but we cannot see this. Okay. Now water is, if suppose water is flowing through the river, so is that water having energy? Yes. And we
Yes,
can
sir.
see this. Okay, this one is flowing. Flowing, it means having some energy, but we cannot see. This is the E. Okay, this is the E. नदीमध्ये पाण्यामध्ये असं कुठे लिहिलेलं नसतं E म्हणून. Okay, but we know that. We can feel that. Okay, so this is the energy that we have discussed. Okay, related to energy. Now we will move for next. Energy that we have seen. Energy is of two types. First one is the internal energy, and another one is the, which one?
External.
Another is the external energy. In internal energy, there again we have types, that is chemical energy. So each and every chemical possesses some amount of energy, that is chemical energy, that is petrol, diesel, kerosene. Some more chemicals are there which possesses that properties in the form of internal energy. Okay. Then atomic energy. In atomic energy, uranium, thorium. One second. Okay. So chemical energy, in which petrol, diesel. Okay, we have covered it. Now next one is the atomic energy. In atomic energy, some atoms possesses energy. By splitting of that energy, we can extract energy from the atoms. Okay, so in that uranium, thorium, is any other atoms? Do you know?
Lithium.
Okay, lithium. See, I'm very weak about that, but if you are telling lithium, then lithium.
Thorium.
Thorium I have told. Thorium, uranium, I know these two. Ukrainium is also.
Candium.
Which one, Vivek?
Candium.
Candium. Okay. Then
Beryllium.
beryllium. Beryllium is the product from the fission of that uranium. Yes. Barium and krypton. These are the side products.
Sir, question काय होते हो?
Question is that do you know some atomic atoms which possesses energy, like uranium, thorium? Do you know some another atoms?
Sodium.
Sodium also possesses. Okay, I don't know exactly, but if you are telling, it means you have checked it. Yes.
All atoms येणार.
All atoms मध्ये एनर्जी असते, बट जास्त कुठल्या आपण जनरल यूज करतो युरॅनियम आणि थोरियम. ओके, so this is related to the atomic energy, which is in the form of internal energy. Then molecular internal energy. So molecular internal energy is the energy possessed by the molecule. So if suppose We will take one example. So you understood this one. So I will ask one question. Do you know term temperature?
Yes, sir.
So what is mean by temperature? Yes, who will tell me?
Supply of heat.
तापमान, it means it is in Marathi. Temperature म्हणजे तापमान, हे मराठी मध्ये त्याचं हे झालं.
Measurement of heat.
Measurement of heat. No. First and very important thing I want to clear here, or I will ask to you whether temperature and heat are the same or different.
Different.
These the two are the different. How many of you agree with this? Please raise your hands. The temperature and heat, these two terms are different. Okay, Aditya, Dhanashri, Vivek, Kunal, Prajakta, Megha, Shivanjali. Okay, those are the students, Pooja. So these students are says that the heat and temperature, these two different terms. Now, how many of you say, okay, how many of you say this heat and temperature both are same? Please raise your hands. Others, please down your hand now. Otherwise, you will be in another participant. Dhanashri, down your hand. Okay. So, what about others? So you think heat and temperature are the same thing or same term? Okay, Pooja says that heat and temperature both are same. Okay. Okay.
No, sir. By mistake.
By
I
mistake.
can
Okay.
raise-
Yeah, Supriya tells Supriya thinks, Supriya thought like that heat and temperature both are the same term. Okay, we will go, we have some terms afterwards, we will see that. But for one thing I have to clear here, heat and temperature both are different terms. Get it?
Yes.
sir.
Heat is not a property of a system, but the temperature is a property of system. आपण जसं पुढे जाऊ तसं आपल्याला ते लक्षात येईल. Now we are on the molecular internal energy. Okay. So molecular internal energy, it means we must know that if suppose this is the water, so this water contains molecules. Correct? I will draw bigger molecules so we can easily understood. Molecules are not seen like this. Am I correct? Or someone have ability to see molecules like this from water? कोणाकडे अशी शक्ती आहे काय की असे molecules दिसतात?
No, sir.
No. But to understand, okay, it is under microscope and we will draw here. So the temperature, you have not tell me what is mean by temperature.
Measure of hotness and coldness. It's
Correct.
called as temperature.
It's called as temperature. Correct, Mega. Generally, what is temperature mean? Temperature means it is the hotness or coldness of a body. It is called as a temperature. But it is on a, for example, now here, if I insert, if this body having temperature of 70 degree, okay, and if I insert hand here, and if I feel hot, then I can say this is the hot body. Okay. Then if I reduce temperature up to 10 degrees Celsius, and if I put hand into that body in that water, so I can say this one is the cold temperature. It means variation in the temperature. Temperature can be varied. Now come to one molecule. Suppose if we consider this molecule, which one, any single molecule, if we consider here, okay. So when I am not adding heat here, without adding heat at a normal room temperature, this molecule having some vibration, am I right? This molecule or every molecule is having some vibrations.
Yes, sir.
Okay. And when I start to add temperature, as the temperature goes on increasing, this molecule which is near to that heat, we are transferring temperature from this side. Okay. So the molecules which is near to that burner or flame of that fire start vibrating very fast. Correct?
Yes, sir.
Start vibrating very fast as they possesses or they absorb energy, and this all get vibrating very fast. Vibrations very fast. So these molecules absorbs energy. And when we add temperature, why this? If these are vibrating molecules, it means the temperature of that vibration of that molecules goes on increasing. Vibration of these molecules goes on increasing. It means the internal energy of that molecules increases. Do you understood?
Yes, sir.
समजलं का सांगा मला आता.
Yes, sir.
Okay. Now, so here temperature is high at the bottom. Okay. Now, why these molecules which is at the surface get or absorb temperature, or they get heated or increase temperature? I have question now. Whether you understood? If I added temperature to these base molecules, why the molecules at surface will molecules or that surface temperature goes on increasing? What is the reason behind that?
ते सर्क्युलेट होतात ना, हाय टेम्परेचर असलेले वर जातात आणि वरचे खाली येतात परत.
Yeah. In liquid, what happen? The molecules which is vibrated, which go in upward direction, and which is having low vibration, low temperature, go in the downward direction. Okay. Now I will take another example. Once again, I will take one shaft, metal rod. Okay. And if I add energy in the form of temperature or in the form of heat at this end. Okay. So after some time, if I am adding heat to this end, whether this end will be hot?
Yes, but sometime.
It will hot on the other side also. Correct, na? Then tell me now why? Because the molecules which are here absorbing energy, and the molecules of here also increases energy. Get it? In liquid, in water, here circulation can happen, but in metal it is possible?
No.
No. Then why it is happening? Yes, this is the transfer of energy. For example, if suppose this is the one molecule and this one is another molecule, here we have one more molecule which is adjacent or neighbor molecule to that molecule. If this molecule, middle molecule, start vibrating very fast. Start vibrating very fast. So what will happen? It tries to transfer this energy to its neighbor molecule. Get it?
Yes.
समजतंय का बघा, लक्ष दिलं तर समजणार, otherwise it is not possible. So these molecules are also vibrating. It means due to that potential difference, once again we can say here we have more potential and here we have low potential, so that the vibration transfers. Now hereafter, when we insert our hand into that water which is hot, so it means it means we are feeling vibration of that molecules. Get it or no? समजतंय का? ज्या वेळेला आपण हे गरम पाणी आहे 70 डिग्री सेल्सिअस आहे, म्हणजे त्याचं व्हायब्रेशन त्या लेवलला इन्क्रीज झालेलं आहे, आणि आपण ज्या वेळेला त्याच्यामध्ये हात बुडवतो त्यावेळेला ते आपल्याला हॉट वाटतं. याचा अर्थ त्या ठिकाणी त्या मॉलिक्युलचं जे व्हायब्रेशन आहे त्याच्यामुळे आपल्याला ते फिलिंग येतं. Get it?
Yes, sir.
So this is called as molecular internal energy. So we have to consider this energy also. Okay, totally it is not possible to check every time, because this all terms comes under the, we can see under the microscope. Okay, so for all of this internal energy we consider letter E. In some books they refer small u, in some books they refer E. Okay, so notation may be different, no doubt about this, in some books as per sequence, because problem is that if somebody writing books and all notations, all write-up are same, then there will be a copy case. Okay, for that reason that writer have to change some notations. Okay, local publications मध्ये बुक आहेत, सपोज रेफरन्स बुक मधून मी वाचलेला आहे आणि त्याच्यावरून मी लोकल पब्लिकेशन करत आहे, म्हणजे बुक लिहित आहे, तर टर्म तरी काय चेंज होणार नाहीत, बरोबर आहे. एनर्जी जी आहे त्याला मी काही वेगळं म्हणणार नाही. एनर्जी, व्हॉट इज मीन बाय एनर्जी? एनर्जी इज द डिग्री ऑफ हॉटनेस अँड कोल्डनेस. इट इज नॉट पॉसिबल, करेक्ट? बिकॉज आय हॅव टू राईट ॲज इट इज. So for that I have to make some changes in my book. So for that reason, whenever I got some chance, like notations, okay, notations हे एक दिलेलं आहे नाव, त्याचं मी नाव नोटेशनचं जर सिम्बॉल बदललं तर एवढा काय फरक पडत नाही, पण त्याच्यामुळे त्याच्यामध्ये डिफरन्स क्रिएट होतो दोन बुक मध्ये. Okay, for that reason in some books u, small u and E is used. So do you understood molecular internal energy?
Yes.
So hereafter, when you are checking the hotness or coldness of body, you see that you are checking vibration of the molecules. Okay. See, this is the same again that we have explained: chemical energy, atomic energy, and molecular internal energy. Now external energy. External energy is of two types mainly, that is potential energy and kinetic energy. See, internal energy is mainly related to heat. Internal energy is mainly related to heat, and that potential energy, kinetic energy is mainly related to work. Okay, there may be some changes, but mainly. Okay, so potential energy here, what is the potential energy? Formula for the potential energy: PE is equal to mg/z. M is the mass of that body, g is the gravity, then z is the height where that body locates. It means, for example, if suppose here we have one box which is at the level of ground, and one box is here which is 100 meters from the ground. So which one possesses more potential energy? This one is first and this one is second, suppose.
First.
First one possess more potential energy if the mass is same. Okay, same box is there. Okay, but due to that height, that is the Z, so this height is Z. When that Z goes on increasing, when that Z, that is the distance, goes on increasing, the potential energy of body also goes on decreasing. Correct? When Z goes on increasing, the potential energy of the body goes on decreasing.
Sir, कसं काय?
तसं नाही?
इनक्रीज होते ना.
इनक्रीज होत आहे. करेक्ट करेक्ट, व्हेरी गुड. बघितलं कोणाचं लक्ष आहे?
सर नाही ते इन्क्रीज होत राहणार नाही कोण म्हणलं आपण.
हा, इनक्रीज होत राहील. करेक्ट करेक्ट, व्हेरी गुड. मी बघितलं, चेक केलं सगळेजण ऐकतायत का, आणि मला कळलं की थोडेच विद्यार्थी ऐकतात. ओके, so potential energy will increase with the increase in that height from the datum or from the ground. Okay, and the kinetic energy is related to velocity when the body moves from one point to the another point. Okay, so here also we can take this example, or we have one more example in the first slide. In first slide, we will go to the first slide here. Okay, so whether the potential energy is more in that stone or the stone which is kept on the ground.
सेकंड स्टोन सर, कारण त्याची व्हॅलिडिटी जास्त आहे.
No, I am asking about the potential energy.
पोटेन्शियल एनर्जी सगळ्यात वर असणार कारण त्याचे स्टोर झालेली एनर्जी आहे.
हा, and kinetic energy
सेकंड मध्ये जास्त असणार, because its velocity is high.
Velocity is high. I will put that another one is here, which is coming from the upper level. So which one possesses more kinetic energy?
Third.
सर तो वॉटरला टच घेऊन त्याच्यात.
It is not water. It is, we can say this one is suppose ground.
देन सर सेकंड मध्येच असणार सर, कारण त्यानं ग्राउंडला स्ट्राईक झालेला आहे. त्याची कायनेटिक एनर्जी परत पोटॅशियम मध्ये कन्वर्ट झाली आहे.
Kinetic energy is again converted into the
पोटेन्शियल एनर्जी.
potential energy. So whether it is correct, it is converted into the potential energy.
नॉट कम्प्लिटली नाही होणार.
How much percentage? Whether it is again converted into the potential energy?
हा, त्याच्यात पोटेन्शियल एनर्जी नंतर सर तयार होणार, पण जी एनर्जी ज्याने कायनेटिक एनर्जी घेतली ती कम्प्लिटली होऊन असं म्हणू शकत नाही. अदर्स फोर्स मध्ये पण ती रिझॉल्व्ह होणार फोर्स.
Yes, very good. This one is very important. This one is very important because I'm asking question to some of the batches. If this is coming from the high level and if it rests on the ground, okay, it strikes on the ground. Okay, so potential energy 10 here, and when it reaches to the ground, it will 0 potential energy. So kinetic energy is not there. Kinetic energy is also not there. Am I right? When it reaches to that ground, kinetic energy is also 0 here.
Yes.
If it is not moving, then kinetic energy is also 0. Potential energy, if suppose some is remaining, or if it is ground, we consider here 0. So where is the energy? Energy गेली कुठं?
ती इम्पॅक्ट फोर्स वेगवेगळ्या फोर्स कन्वर्ट झाली सर. ते हीट मध्ये जेव्हा ते इम्पॅक्ट होणार तेव्हा हीट निर्माण होणार, ती ब्रेक होऊ शकणार.
Correct, very good. Okay, you are, I think Sabi, you are very clear about that concept. Okay.
Yes sir, 11 to 12 मध्येच कंप्लीट झाले.
Yeah, you are very clear about that. But many students are not clear about that. They are thinking only this is potential energy. When it drops, it is converted into kinetic energy. Finish. But what happens when it reaches to the ground? Okay, many of the students, okay, 90 to 95% students say that the energy vanishes. And if I ask energy conservation law, they tell that energy neither be created nor be destroyed. So it is opposite. Am I correct? whether this example is not suitable for that energy conservation law. So here, when it reaches to that particular ground level, the forces will resolve. If this one is the hard surface, if this one is the hard surface, or some we can say, if suppose here if tiles are there, the tiles get heated. If you check, okay, जर तुम्ही एखाद्या लोखंडावरती दुसरं लोखंड मारत असाल हातोडीने वगैरे, ओके, तर तुम्ही चेक करा की ती हातोडी आणि तो जो ज्या लोखंडावरती आपण मारतोय ते दोन्हीही लोखंड गरम होतात. कधी केलंय ऑब्झर्व?
आणि सर त्यातून ही लाईट पण येते ना बाहेर?
हा, लाईट पण येते बाहेर. म्हणजे ती जी एनर्जी आहे ती व्हॅनिश होत नाही. इट रिझॉल्व्ह इन डिफरंट फॉर्म्स ऑफ एनर्जी. ओके, so this is related to the potential energy and the kinetic energy. Okay, 1 second, we will move ahead. So these are the various applications. There are so many large applications of that thermodynamics in industry, in day-to-day life. So in industry, mainly mechanical industry, we can use this thermodynamic applications in combustion engine, steam and gas turbines, jet propulsion, nuclear power plants, then power absorbing devices like compressors, pumps, refrigeration, and air conditioning plants. Okay, so these are the examples or the applications related to mechanical engineering. There are so many applications, but these are the applications from the mechanical engineering. There are so many applications from the mechanical engineering which are not written here also. Okay, so these are the pictures captured from many devices. So to understand how energy interaction takes place and how thermodynamics is very important in this all not structures actually, in these all devices. Okay, now one more point is here, that is the microscopic and macroscopic. So these are the two study approach. These two are the study approach. How to study, if suppose some system is given to you, how you are study this system. So there are two ways mainly. In that, first one is the microscopic view and another one is the macroscopic view. I will give you a simple example so you can understood. Now, again we will take water. And if these are the molecules, here we have some molecules. I will consider this one molecule. Okay, this is related to microscopic study point. If I highlight this molecule and I focus only on that molecule. So initially this molecule having 10 degrees Celsius temperature. Okay, then vibration is that much. Okay, you can unit vibration also in hertz. Vibration is that much. This molecule is rotating about itself with some speed. Okay, these are some readings at initial. When I add temperature to this total water, so whether all these molecules absorb energy or not. कळालं का? मी जर याला टेम्परेचर वाढवल्या पूर्ण बॉडीला, सगळेच मॉलिक्युल्स त्यातली एनर्जी ऍब्सॉर्ब करणार आहेत. बट वी डोंट what we can say, we don't care about that about other molecules. We only focus on this molecule. So as the temperature goes on increasing, the vibration of that molecule also goes on increasing. It means it shows more temperature. So we get temperature about 20 degrees Celsius. Okay, again, it is up to 30 degrees Celsius. So vibration also goes on increasing. So this study is come under the microscopic approach or microscopic viewpoint. Get it?
Yes, sir.
Only one, we focus only on one molecule. We don't care about other molecules. So this study is called as microscopic viewpoint. For example, recently in COVID situation, I think in March 19, okay, it was discovered. It was discovered earlier than March.
January, sir. January.
Okay, January. If our scientists want to study the coronavirus, whether they will take all coronavirus together and they will study, or they will take out one coronavirus to check the properties, to check how it spreads. So which method they will follow?
Only
One
one.
coronavirus.
Yeah, they will take only one coronavirus. So this type of study, this approach of the study is called as the microscopic viewpoint. Okay. Now, if I insert thermometer, if I insert one thermometer here in that water, so mercury inside that temperature, mercury means part. So mercury which is inside that thermometer will go in upward direction, correct?
Yes, sir.
Yes, sir.
So whether that increasing level of that mercury is effect of single molecule, or it is the average of total molecules which is in contact with the thermometer.
Average molecule temperature.
It is the average. So whatever results we get here, these comes under the macroscopic viewpoint. This comes under the macroscopic viewpoint. Okay, so we get temperature. We can't say, if we dip that thermometer in the water, and we can't say like that number of that molecule have that much temperature. We can say this temperature, this is the temperature of this total water, correct? Understood or not?
Yes.
sir.
So this one is the approach of macroscopic. There is very small difference, microscopic and the macroscopic. Okay, it is related to thermodynamics. If suppose I'll take another example, if suppose this is the pipeline and water is flowing from this pipeline up to this another end. So microscopic, I will tell first microscopic. In microscopic viewpoint, I catch one molecule and I study that. Yeah, I focus on that molecule when it moves in this direction up to that end. And whatever is behavior, I will record it. Okay, irrespective of other molecules. या एका moleculeचं behavior कसं येतंय ते मी record करेन. So such type of study comes under the microscopic viewpoint. And if suppose I want to check velocity of water, then I will insert here some tube and I will check. So at that section 1 or 2. So whether that velocity is of single molecule or average of that all molecules or that water.
Average of all that molecules.
Yes, correct. So checking velocity comes under the macroscopic viewpoint, and checking behavior of that single molecule comes under the microscopic viewpoint. So up to that, whatever we have learned, okay, which method we have followed? What do you think?
Microscope.
Microscopic viewpoint we have followed, or we have followed macroscopic up to that in our academics?
Macroscopic.
Macroscopic.
Macroscopic, correct. So we have followed macroscopic study point. Okay. Henceforth also, hereafter also, our approach is macroscopic viewpoint. Okay, because we do not require to go up to that much of deep for the molecules. So this is required for the scientist, and this is having microscopic viewpoint is for different things. Okay, that macroscopic viewpoint we have to follow hereafter also. Get it? Microscopic and macroscopic.
Yes, sir.
Yes, sir.
Okay.
Yes.
तुम्हाला समजतंय ना मी शिकवलेलं काय?
हो सर, समजतंय ना.
Okay.
Yes.
Okay. Now working substance. Okay, we will see working substance today, and then we will stop here. So working substance is very common thing. Working substance means the medium. Working substance means medium to transfer energy. To transfer energy from one form to the other form. Mostly fluids are the working substance. Fluids, it means liquid and gases. Get it? The fluids are working substances. For example, in a reciprocating pump, which is the working substance?
Liquid.
Liquid fluid.
Yeah,
Yes.
correct. Liquid is the working substance because we are adding mechanical energy. That is, by mechanical energy, we can create, or we can increase pressure of that water. And by increasing pressure, it means if we are increasing pressure, it means we are transferring energy to that water. Okay, we have energy in the form of mechanical, and we transfer it into the hydraulic energy. By using that, we can lift the water. Okay. Now, what is the working fluid or working substance in compressor?
Air.
Air.
Air, correct. Here again, same thing. Air is the working substance, or sometimes it is not related to gases actually. Compressor is mostly used for the air. In IC engine, internal combustion engine, which is the working substance?
Fluid and air, both.
Okay. Air and fuel, because to burn that fuel, petrol, diesel, the oxygen is required. For that reason, we are mixing air and fuel together, and then we burn it. Where they mix? Have you seen carburetor to your two-wheelers?
Yes.
So the function of carburetor is to mix air and fuel together, and it passes to the engine. Okay. So working substance, you can observe here that working substance can absorb or reject heat. They have capacity to absorb some amount of heat, and whenever it is necessary, they can reject also. Okay. It does work, or work is done on it. Okay, that we can understood afterwards in second point, that is heat and work. It is compressed or expanded, heated or cooled so that desired energy transfer is achieved. So we can transfer heat, we can compress them, we can expand them, okay, we can heat them, we can cool them. So these are the working substances. Okay, you can say metal is also working substance, but generally we consider liquid, that is fluids, are the working substance in most of the devices. Okay, so these are the working substance. Have you understood?
Yes, sir.
Yes, sir.
Okay, so with this we will stop here. The remaining part we will see in the next lecture, but put your roll numbers and mute yourself so I can take your attendance.
सर
यस.
ही आपली पीपीटी आपण अपलोड केली आहे का?
नाही, अजून नाही केली, करायची आता.
ठीक आहे सर.
आजच चालू झालं ना आपलं पीपीटी. आणि मी मगाशी सांगितलं सुरुवातीला पीपीटी, नोट्स आणि एमसीक्यू तिन्ही अपलोड करतो.
ठीक आहे सर, नो प्रॉब्लेम.
Roll number 1, 2, 3, 4, 5, 6. Roll number 6 absent. 7 absent. 8 absent. 9, 10, 11, 12, 13, 15, 16, 17, 18, 19 absent. 20, 21, 22, 23, 24, 25, 26, 27, 29, 30, 31. 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53. 53 is absent for morning lecture also. 54, 55, 56, 57, 57, 58, 59, 60, 61 absent. 62, 63. 64 is present here. Okay. So roll number, I'm not calling roll number, absent roll numbers. Okay. You have written roll numbers into the chat box. That is taken. Okay, thank you all of you. We will stop here.
थँक्यू सर.
Sir, wait 1 minute.
Okay. What are you doing?
Okay, sir.
What done you? Prithviraj? What you
Yes,
done
sir.
now? What you done now? काय राहिलं तुमचं?
Chat box मध्ये रोल नंबर लिहायचा राहिला होता, लिहिला सर.
ठीक आहे. मी घेतले अटेंडन्स इकडे तुमच्या ह्याच्यावरून पार्टिसिपेंट वरून. ओके.
38 present.
38. Yeah, 38 is present here. Okay.